Okay, we are on test review video 4. This is the second page of the stapled packet. It looks like this. It's kind of a grainy looking copy. It's actually pages 65 and 66 out of your book. If you'd rather follow along there, that would be fine. 65 and 66. And what I'm going to do is move this way up in the corner so we can see it. I realize maybe you can't see the whole thing, but I'll do my best. 3.1, classifying rational numbers. The first question reads, 5 friends divide 3 bags of apples equally between them. Write the division represented in this situation as a fraction. This should sound familiar. We've done problems like this before in lesson 3.1. The very first problem we did, in fact, so long ago, was about kids who went to an art class. And there were 3 blocks of clay in this art class. And those blocks of clay were divided by 4 friends. Well, if we take all these numbers out, we have 3 divided by 4, and that was equal to, you remember the answer was 3/4. And the conclusion we drew that day was that when you're dividing, when you have a division problem like this, and if you can't actually solve and get a number, there's not a calculation to be made, what we concluded was that the dividend, the first number, instantly became the numerator, and the divisor, the second number, instantly became the denominator. And 3/4 doesn't simplify, so that actually was the answer. In that problem, it was 3/4 of a block of clay. That's how much each friend got. Now, how does that relate to this problem? Well, let's read the question and see if we can draw a similarity. This one is 5 friends divide 3 bags of apples. Now, some kids are going to be tempted to just take the first word, 5, and put it first. Second word, 3, put it second, do 5 divided by 3. And that's actually not going to be right because of something we've talked about. The structure of that clay problem and the structure of all the problems that we've done like this was always you take the number of items and you divide by the number of friends or people. Well, the items in this case are 3 bags of apples, and the friends in this case are 5. So the answer to this one's actually 3 divided by 5, and we can't compute that, so I'm going to take my dividend and make my numerator. I'm going to take my divisor and make it my denominator. 3 divided by 5 is the same as 3/5. So what do you put on the line? Directions say write the division represented in this situation as a fraction. Technically, you really only need to write 3/5. I might write this. 3 divided by 5 equals 3/5. That shows a really good understanding of this problem. All right, let us move. I'm going to move this up so we can see the next problem. So the next set says write each rational number in the form of a over b, where a and b are integers. So look at the first one, 5 and 1/6. A lot of kids look at that one and say that is in the form of a fraction. But if you look at this, what I need in the form of this fraction right here, if you look at a over b, I need a numerator and a denominator. So I can't have that whole number there. So how can I make 5 and 1/6 into a fraction? Well, it's simply just make it into an improper fraction. So I would go 5 times 6 is 30. Plus 1 is 31. The answer to this one is 31/6. Now I have just a numerator and just a denominator. What about number 3? Well, in number 3, you have to remember that all whole numbers and all integers can be written as a fraction over 1. So -12/1 is the answer to number 3. Next set says, determine if each number is a whole number, integer, or rational number. Include all sets to which each number belongs. So on these, I hope you can remember this. I'm going to go ahead and draw this. Remember that we had a Venn diagram, and we had an inner circle that was whole numbers. And then we had another circle that was integers. And the reason why the whole number circle is inside the integer circle is because all whole numbers are integers. And then we had one last circle that was called rational numbers. And the reason why the integer circle is inside the rational number is because, by definition, all integers are rational numbers. You can go back and review this from lesson 3.1 if you forgot. Now, what we're supposed to do is place these numbers where they go and then decide which set they belong to. So -12 is obviously an integer. That's exactly what it looks like. That's what integers look like. They're whole numbers with positive or negative signs. It doesn't go into the whole number circle because by definition, -12, whole numbers are positive. So it doesn't go there. But what kids might get wrong on this one, let me go ahead and finish the next one and then I'll move it out of the way. Positive 7/8 is just a rational number. It goes out here. So let's review this, because this is where kids might get number 4 wrong. Kids won't get number 5 wrong. Kids are going to say rational numbers for number 5, and I kind of have enough room. I'll squeeze it in there. The correct answer to number 5 is rational numbers and nothing else. Be careful about this next one, though. Number 4, I'm going to go ahead and make a little space and add a line. I know it's a little messy. We're just going to have to live with it. So I'm going to make a line here. And here's what kids might do on number 12 on accident. If on number 4 on accident, if you think that negative 12 is an integer, then you're not going to get the whole thing right. Because what we just talked about and what we learned about was that the integer circle is inside the rational number circle. I'll go highlight it. Negative 12. This circle right here, I'm not saying it's inside the whole number circle, but I am saying it is inside the integer circle, and it's also inside the rational number circle. So negative 12 is not just an integer, it's also a rational number. Just remember that if you're in one of the inner circles, it ends up being in more than one of those. Okay, let us move on. So lesson 3.2, a little bit further down the page, is identifying opposites and absolute value of rational numbers. And number 6 simply asks you to graph. Some of these are pretty easy. Negative 3, let me move it over just a bit more, make sure we can see it all. Negative 3 is on the number line, you don't have to do any estimating there. 1 3/4 is between 1 and 2, but definitely closer to 2. So I'm going to put it about 3/4 of the way over and call that 1 3/4. Negative 0.5, you have to know that's negative 1/2. That's going to be between 0 and negative 1. So that's going to be negative 0.5 or negative 1/2. And the last one is positive 3. And that's what I was supposed to do for number 6. So if you graph those, you're good. Number 7 says find the opposite of 1/3 and of negative 7/12. Well, the opposite of 1/3 is just negative 1/3. And the opposite of negative 7/12 is just positive 7/12. Number 8, find the absolute value of 9.8 and of negative 10/3. Just remember what absolute value means. It means distance from 0. 9.8, whether it's positive or negative, is 9.8 spaces from 0. So the first answer is 9.8. If you think to yourself, how could the absolute value be the same thing? Well, when it comes to a positive number, like 9.8, the absolute value is itself. You should also remember that when it comes to a negative number, like negative 10/3, the absolute value is its opposite. So the second answer here, negative 10/3 is 10/3 spaces away from 0. It's 10/3. Remember, absolute values are always positive, except technically for 0. Alrighty, let me move this up. We are on number 9. It says comparing and ordering rational numbers. Over the last week, the daily low temperatures in degrees Fahrenheit has been negative 4, 6.2, 18.5, negative 5.9, 21, negative 1/4, and 1 75/100. List these numbers in order from greatest to least. At first glance, this one might look a little bit overwhelming. First of all, let's pay attention to the fact that it's greatest to least. That means all my positives have to go first and all my negatives have to go last. But if you look at this, you might think this is overwhelming. You've got decimals and tenths, you've got fractions with a denominator of 2, you've got a fraction with a denominator of 4, you've got a decimal in hundredths. It's pretty complicated, except one thing that we've practiced recently is, do you remember that the whole number is really the most powerful thing? And let me talk about that as I start to get some answers. I'm going to go ahead and point out some answers that it cannot be right now. It cannot be any of my negatives. So right now, I'll come back and unerase these later. Remember, I'm looking for my greatest value. It can't be negative 4 or negative 5.9 or negative 1/4. I've got 4 positives to choose from. I've got 6 and something, 18 and something, 21, and 1 and something. Well, just use common sense. Obviously, the greatest value there is 21. Obviously, the next greatest value there is 18.5. If you're worried about the fractions, then you're kind of overthinking it. Obviously, the next greatest value there is 6 and 2/10. Obviously, the next greatest value there is 1 75/100. I got all my whole numbers there, and I didn't have to use any of my fractions. Now I'm going to go back and unerase all of my negatives, and I'm going to cross off my positives because I've got those. I've got that one on there, I've got that one on there, I've got that one on there, I've got that one on there. I've got 3 negatives, and I simply need to remember that when it gets into the negatives, I'm starting at 0, and I'm working my way left on the number line, so that means they're becoming more negative. Well, the least negative number there is just negative 1/4. That's barely past 0. And then if I'm thinking about a number line, if I'm traveling down the number line, I would come to negative 4 next, and I would come to negative 5.9 last. So while that looked complicated, it ended up actually being a pretty easy problem. So that's the end of this video. We'll have one more video showing the last page.